like creating a table or stored procedure in each host. So something like that. So that's all I have.
Cool. First of all, thank you, Balaji, for joining, and thanks, folks, for joining in this session. I have started my recording. So now, coming back to the question which Balaji posed here, that is how will this SQL monitor be able to handle, say, 1,000+ servers? Okay. How do we handle creating of linked servers, creating of those stored procs and everything? So the short answer is you don't need to do anything manually. SQL Monitor setup script will take care of each and everything for you. Okay, you don't need to worry at all on anything. So we will see that in today's demo. Uh, just to
Sure.
explain you guys, I already created around 7 to 8 videos on SQL Monitor. So just type ajaydwivedi.com/YouTube/SQL Monitor. You will end up on this particular playlist of SQL Monitor, in which video number 1 to 5, those are explaining one dashboard at a time. Video number 6 and 7, in these two videos, I am explaining how to set up SQL Monitor on a non-domain joined host. Okay, so in these two examples, I have a server, SQL Server, which is not joined to any domain. Today, plus in these two videos, I also showed you that how to create an inventory server. So the same server which we baselined in these two videos, the same server was acting as our inventory server also, or central server also. You can call it either central server or inventory. Today we will take a different demo altogether. So in today's demo, I already have an inventory server in my lab environment. I want to add another server in SQL Monitor infra. Okay, and that server would be just a server that I want to monitor. Okay, so if you want to set up a central server, first you need to watch these two videos, and then if you want to add further servers in your baselining inventory, then that is what this today's demo is all about. Okay, here I saw somebody raising hand earlier, Kranti, I think. So Kranti, you can unmute yourself, I think.
No, fine, Ajay. Actually, by mistake it has.
Awesome,
Yeah.
awesome. So let's proceed. Of course, one more request: kindly do subscribe to my channel so that you can stay updated. Uh, my idea of my idea is like this: I want to keep creating various scenarios and cover those topics on how to resolve those kinds of issues using SQL Monitor. Previously, I have even written multiple blogs on how to resolve what kind of issue using SQL Monitor. For example, there are two blog posts on how to resolve high CPU using SQL Monitor, and I have written one blog post for resolving high memory grant issues on SQL Server. This one has been even appreciated by Brent Ozar also, this memory grant one, so probably you should check this out. So that's what I intend to. In future, I want to create more scenarios covering various issues that I face and how I use SQL Monitor to resolve those issues. So there is a question: do you upload this whole session on YouTube? Yes, that is the whole intent. I want to keep everything as much as free as possible. I only charge for my time, not for this tool at all. It is entirely open source, and not for these videos also. They are free. You can directly go to this playlist and watch those. Even this session will go there on YouTube. So let's proceed. Let's,
Ajay, one last thing I have is so when comes to the security part, so if we onboard this tool to our environments, right? So
mhm.
uh, any security issues we face, like will you be able to monitor our servers, something like that? Since you manage this tool, do you have?
No, No,
that
not
kind
at
of
all.
access?
Not at all. I don't have any say in this tool. Okay. I mean, in the background, I'll show you. So,
Yeah, and that one, and when, see, suppose if some issue arises for us uh,
hmm,
while monitoring, so something script issues or something,
hmm.
so will you be able to help us in that case?
For my personal time, I charge.
Okay,
Okay. But in case script is not working for your case, for you, or there is some bug, okay, or there is some enhancement that you need, kindly feel free to go to that GitHub repository and raise a issue up there. Okay, so you can come up to SQL Monitor, okay, and go to Issues tab, and here you can raise a new issue for me, tagging what kind of issue it is, whether it is a bug or a feature request.
sure,
Okay,
definitely. Thank you so much. Yeah, you
and
can proceed.
definitely there is nothing that I track in this. Only thing is initially we asked for the DBA mail ID. That's all the only thing we do. So in wrapper we have a parameters for asking DBA mail ID. That's all. And you will not find my email ID or anything related to me in anywhere in this script at all. I mean, if I try to find out Ajay keyword anywhere, you will see my name only, no email IDs anywhere. Okay, so here you can see copyright Ajay Dwivedi. In code of conduct, it's a markdown. So markdown you never use anywhere. So you will not see my email IDs anywhere. Okay, there is this script which says database mail using Gmail. Okay, so in this is something I kept it here for people to understand how to set up a Gmail based mail profile in your SQL Server if you are using your personal lab environment. Okay, for example, like me, if you practice performance tuning in your laptop, in those cases you will not have a organization provided SMTP server. So this is a sample script which you can use to set up use your Gmail account to set up a mail profile on SQL Server. Okay, apart from that, I am not sending any mail to myself anywhere in any of these codes. You can see no code has my email ID at all. So don't worry about
Sure.
security issue. Yeah.
Yeah, sure, Ajay. Thank you.
So let's proceed. Just to give you an idea, what we are going to do today is I have my lab environment. In my lab environment, I have this domain controller, so you can ignore it totally. I have another virtual machine, SQL Monitor. This is my central server. This is my inventory server. Okay. I have already baselined my central server or inventory server. So if you want to learn this one, you need to go to that playlist and watch these serial number 6 and 7 videos, how to baseline your inventory server. So this SQL Monitor is my inventory server or central server, you call it. This SQL practice and workstation, these are two other virtual machines where I practice my performance tuning mostly. So these are also baselined in my SQL Monitor infra. Today what we are going to do is we are going to baseline a few new machines, like I have this machine demo and I have this machine experiment. So we are going to add them to our baselining. Before that, let's ensure that those machines are not present in our baselining infra. How can I ensure that? If I open this dashboard, the first dashboard in SQL Monitor infra, that is monitoring live all servers. If I open this one and I expand this first row. So in the first row, I have this panel which will tell me all the servers which are live, okay, which are online and are baselined in our infra. So right now these many servers are online and they are baselined in my SQL Monitor infra. So I have one machine, host machine. The name of the machine is workstation. If you remember this one, last one. So this workstation machine has 3 SQL Server instances installed on it, one default instance and 2 named instances. Okay. So all 3 SQL Server instances present on the same host, they all three SQL Server instances have been baselined using SQLMonitor. So that's why I see three line items for workstation. The first instance, default one. Second instance, SQL 2014. That is the name of the instance. And third one is SQL Express. So this is 2019 version. This is 2014. This is Express edition. The next one is SQLMonitor, which is my central server itself. So if you are setting up SQLMonitor for first time in your environment, first you need to baseline your central server or inventory server. Once that is done, then you can baseline other machines. So that's how I did. First I installed SQLMonitor on this machine. Okay, and that machine is my central server. Then I baselined each of these machines one by one, or each of these SQL servers one by one. So I have pretty much these. Plus, I have one extra which seems to be offline. That's why it is appearing in this second row, which says critical SQL instance is offline. Okay, so this particular instance is offline, and you can see here it is actually it is a SQL cluster, and all the nodes of that SQL cluster, that is SQL DRA, SQL DRB, SQL PROD A, SQL PROD B. So those are offline. That's why this SQL cluster is offline. And I have baselined the SQL cluster altogether. So that's why it is appearing in offline state here. And that is the whole purpose of having this all server dashboard. So in this all server dashboard, I usually monitor if there is any server that need my attention. So there is one server which need my attention. It is currently appearing to be offline, or at least not accepting user connections. Then I have another server which is appearing in this third row. So third row says require attention. So this any server which is appearing in this third row that need some kind of DBA help. So why this one is appearing? Because it has low available memory here on the host level. That's all. Otherwise this server has good enough CPU at OS level and SQL Server level, and no blocking at all, no memory rent issue, and SQL connections are also okay. So this was the first dashboard. So whole idea of explaining this dashboard is I wanted to tell you guys that one second. I wanted to tell you guys that I don't have those servers in my inventory right now. So the servers which we want to take as a demo is demo server and experiment. So demo and experiment are not baselined till now in my inventory. Just to validate the same thing, what I will do is I will show you the raw tables that I usually use that happen to be in background. So if you go to your central server, okay, as I said earlier, SQLMonitor is my central server or inventory server. So if you go to your central server and then you browse to your inventory database, in there we create couple of tables. Okay, the one table is dbo.instance details. This table records whatever SQL Server instances that have been baselined in your environment. Okay, this table is present in almost all the instances, but on the central server, this will have many more rows, one row for each SQL Server instance which has been baselined in your environment. So in my lab environment, I have these many instances which have been baselined. So if you remember, these were showing in online state, only SQL prod was showing in offline state. I can validate all that information here. So you can see is available equals to 0. So this SQL prod was showing offline. That's why it is having is available equals to 0. Rest of them are in online state. So I can see 1. So pretty much I have these many instances in baseline state. Let's proceed for baselining our first SQL Server instance. So we are going to take our experiment instance today first. So let me open my experiment instance. Right now it is in shutdown state, this experiment box. So ready for SQL Server monitors demo non-domain. I want to take the domain based method today because we already have 2 sessions which are on non-domain kind of setup. Ready for SQL monitor demo. Yes. So let me start this snapshot. Cool, it is online. Let me start this machine now. We have nothing to do with this machine. We don't need to RDP or anything. Just for clarification purpose, I am taking RDP and show you guys how this looks like. So the first thing is this machine is joined to domain. That is the first scenario here, which usually happens in organizations. Okay. So the machine name is experiment and it is joined to my domain network, that is lab.com. So the full name of the machine is experiment.lab.com. Second thing is this machine has only single instance of SQL Server. Okay. But that happens to be a named instance. So the instance name is SQL 2019. I don't have any default instance here. So what I have done is I have configured this instance in such a way that it listens to the default port. So in short, what happens is, since it is listening to default port, even though it's a named instance, I can connect to this named instance just providing the host name. I don't need to suffix the instance name while connecting to this particular SQL Server instance. Let this SSMS launch. Next point here is this SQL Server instance services, they are running under domain service account. Okay, you can see here the service account is lab/SQL services, which happens to be a domain service account. So you can see first I am going to connect to this instance using two-part name, that is host name / instance name. I can even connect to this instance just by the host name. Just because I have configured this instance in such a way that it even listens to port 1433, which is the default one. Okay, starting with this, I want to show you that there is nothing behind the scenes. We don't have any database on the server right now apart from the system databases. No databases at all. So we are going to baseline this particular server in our SQLMonitor infra. That's it regarding this server. Let's go to our client machine or my laptop machine, whatever you call, where I download all the setups and everything for SQLMonitor, and from there I launch everything. Okay. So if you guys don't know how to do that, you need to watch the previous videos that I have created. Usually what I do is I have this Visual Studio Code installed everywhere. So I usually do Control-Shift-P, git clone. I provide the URL of I provide the URL of SQLMonitor, which I copy from here. Click on this, under the code, you copy this URL, and in that pop-up for git clone, you simply provide the URL here, and then you press enter, and it will ask you where you want to download this SQLMonitor repository altogether. That's what I did. It's already available on this box, so I'm not going to do that again. Next thing is, so what I have done is, in my case, I have already downloaded the SQLMonitor setup, GitHub repository setup here inside my GitHub folder on F drive. Another thing you want to do is, which I shared in previous video sessions also, is you can create folders. Okay, create a folder either by the either by the name work or either by the name private. So let me create a folder by name private. Why I suggest you to create these folders, because once you take the latest from the GitHub, these folders, they are never touched. Okay, they are ignored by the GitHub repository altogether. So they will never be overwritten. So anything that is sensitive to your environment, anything that you don't want to be overwritten from the GitHub, whenever you are taking the latest, you should keep them inside either the work folder or the private folder. So let's say I created a private folder. Now let me take latest from the GitHub. So git pull and it is saying already up to date. So my GitHub repository is already up to date. Next thing I want to do is, once I am in private folder, I want to go to SQLMonitor folder. So within the SQLMonitor repository folder, there is another folder, SQLMonitor. I want to go there and I want to copy these two files which says wrapper, and I will paste them in my private folder or work folder. So there I go. From here what I can do is, let me close all other earlier ones. So from here, go ahead and open PowerShell ISE in administrative mode. Click on this open icon and browse to your SQLMonitor repository folder. In there you created a private folder if you remember instructions, and in the private folder I copied these two wrapper scripts. So simply select both of them and it will open, both of them will open here. I am interested in setting up SQLMonitor for experiment server. Give me a minute, guys. हाँ, अरे तो मैं मीटिंग में हूँ यार, रिकॉर्डिंग मीटिंग. Sorry. So if you guys remember, what we want in this demo is, we want to set up SQLMonitor, or we want to baseline this experiment SQL Server instance in our inventory. Okay. So let's start here. First thing first, what you need to do is, you need to open the wrapper-install SQLMonitor.ts1 script. Okay. Second thing, you want to scroll to the this line where it says this script name, install -SQLMonitor.ts1. So this is the main script. This is the main function which does all the magic in background. You need to ensure that this path is absolutely correct. I explained about this thing in my previous video sessions also. So say that you have downloaded this SQLMonitor in some other drive. Say I have downloaded this in H drive, G drive, or C drive, or E drive. Then you need to ensure that this particular path is absolutely correct, and this script is easily reachable. You can simply do a test that by copying the path and saying test path here. Okay. So it is saying test path and that script to be true. That means that script is easily reachable. Another thing you can do is, you can look for the help for that script path. So simply type get help and provide the path here and say show window. If this command returns result, then that means that script is easily reachable, and you can read about all the parameters that are available in that script here. Each of them has been explained here. Cool. So in short, my wrapper script at least is configured okay. This script is easily reachable. So this, at least this point is correct. Now let's start from the top. So we are calling this script by passing all these parameter values. So this is called the concept of parameter splitting in PowerShell. So I'm using that parameter splitting here. Okay. And where I have defined those parameters have been defined from line number 7 till line number 47. Okay. So in this $params variable, I am defining all the parameters that I want to pass for this PowerShell script. Let's see what exactly I need to do. So if you guys remember, I can connect to that experiment instance using both single part name, okay, and using two part name. That means host name backslash equal 29, I think it was, host name backslash instance name. I can connect to that instance by either way. Also, I can connect to that instance using IP address also. So ping experiment, I can get the IP address here. Come on, bro. So I can connect to that SQL Server instance even using IP address. There are three ways in which I can connect to that instance. This SQLMonitor infra or tool allows you to baseline a SQL Server in any way the server is reachable. So I can baseline this server either by the one part name, either by two part name, or even with the IP address here. Okay. So that is the idea here. Usually in organizations, we use host name or SQL Server instance name for baselining the servers or for connecting the servers. So what I will do is I will use this experiment /SQL 2019, or let me make it more, since I have only one instance on the box, let me baseline it with just by the experiment keyword. So let's go back to our PowerShell, and here in this parameter value which says SQL instance to baseline, that means the SQL Server instance that I want to add in SQLMonitor infra, you need to provide that name. So experiment, that is my SQL Server instance name. Then you need to specify a local database on that instance where the data or captured data or baseline the data would be saved. So this DBA database does not exist. So I need to create that database manually here. So let me connect to that instance, and I can see that there is no DBA database. So let me create that database first. It is not a requirement. It is not a requirement to name it just by the DBA. If in your organization you guys are using some other name, say you are using DBA admin, if you are using DBA tools, if you are using say underscore DBA, if you are using say admin utility, whatever name you guys are using in your organization, okay, you can use existing databases also with whatever name they are. This tool is entirely flexible. Your DBA database do not have to be named as DBA. It can be of any name. So you can see here in my current inventory setup, all the databases are of DBA name, but let's take in this example a different name altogether. So what I will say is DBA admin. Say that I call this database DBA admin. I'm going to create a simple recovery database, and the name I have given to this database is DBA admin. So I need to ensure that this database name I provide properly here also. So here I am going, instead of DBA, I am going to use DBA admin. I hope it is not confusing you guys. The whole point of this thing is, if there is any existing database in your servers, production servers, which you use for dumping DBA related stuff, DBA related databases, and you don't want to create another database with a DBA name, you can even use the existing databases, whatever you have in your environment. This SQLMonitor is entirely flexible in terms of what is the database name. Okay. So there is this. The next thing that I have to specify is path of DBA tools repository that I have downloaded locally on this workstation machine. Remember that there are three machines involved in this baselining. First machine is from where I am launching this script. So I am launching this wrapper script from my workstation machine, which happens to be my office laptop or desktop. Okay. In your case, it can even be your inventory server. Okay. So I could have called this script from my inventory server, that is SQLMonitor. Okay. But I prefer to do everything in my laptop, in my office laptop or in my personal laptop or desktop. So this workstation is something like that only for me. So this workstation machine, I do everything on this machine. So I am launching or I am calling all the PowerShell scripts from this workstation machine. But the machine or server, SQL Server which I am baselining, is this experiment one. Okay. The third thing is my inventory server or central server happens to be something different server. So if you remember correctly, my inventory server name is SQLMonitor. So here in line number 14 and 15, the parameter names are inventory server, inventory database. I have to ensure that I place proper names for inventory server and inventory database. So in my lab environment, my inventory server name is in SQLMonitor, and the inventory database that is present there is DBA. So that's what I am going to provide here. Inventory server happens to be SQLMonitor, inventory database seems to be DBA. So talking about point now, this parameter DBA tools folder path, you have to watch the previous demos in which I downloaded the DBA tools repository from GitHub, and then you have to provide the path of that local DBA tools repository. Okay, on my current machine, on my workstation machine from where I am calling these wrapper scripts, the path of DBA tools happens to be F GitHub DBA tools. So let me show you guys where this one is. F GitHub DBA tools. So you can see here this path which I have provided for this parameter DBA tools folder path, it is present on my workstation machine here on F GitHub DBA tools. You can download this from GitHub altogether. What is the use of this path? So what happens in background is, we don't want you to spend too much time in installing DBA tools on each and every machine. Okay, we use DBA tools in background to run PowerShell scripts. DBA tools is a famous community owned PowerShell module through which you can carry out lot of DBA maintenance activities, DBA related stuff. Okay, and we are using the same famous DBA tools PowerShell module in background for carrying out most of the activities. So what we are ensuring here is, whatever DBA tools repository scripts you download, you provide the path of that DBA tools repository script local path here in this parameter, and then we copy that repository path on each and every SQL Server machine that you are baselining. Okay, so right now on experiment machine, I don't have DBA tools installed at all. If I go to my experiment machine and if I go to C program files, Windows PowerShell modules, I don't see DBA tools installed here. Okay, there could be other path also for installing DBA tools. So rather than showing you all the paths, let me show you a simple way through which we can find out whether DBA tools is installed on my box or not. So the way is pretty easy. What you can do is, you can say get module, okay, and you can provide the name of the module, and you can say list available. So if DBA tools is installed anywhere in your machine, if DBA tools is installed in experiment machine, SQL Server machine, then I will get result from this. If it is not installed, I will not get any result. So you can see I did not get any result. Same thing if I do for other modules which are installed. For example, a SQL Server module is installed on every box whenever you install SQL Server Management Studio. So if I call this one, I will get some result. Oh, it means even SQL Server module is not installed. That has to be explicitly installed. Okay, no worries. So I can copy these two and I can show you these two on my workstation machine where DBA tools is already installed. So if I copy them here and if I run this first line, so you will see that I get result here. So on my workstation machine from where I launch every PowerShell script, this DBA tools module is installed on two paths. It is installed on this directory and it is also present on this directory. Okay. The intent of providing this particular parameter value here is, we take this local copy of DBA tools repository and we paste it in one of the PowerShell modules path on the SQL Server which we are baselining. So in short, this folder would be copied on experiment machine in one of the PS module paths. So usually this is how you find out PowerShell module paths that are valid for your machine. So if you run this environment PS module path, you will see all the PowerShell module paths which are valid for you. So in one of these paths on the remote machine, this local copy of DBA tools would be copied. So that's the whole purpose of this parameter here. Let me clear my screen. Cool. So getting back to next parameter, inventory server, inventory database, we already discussed that. Next one is line number 16, DBA group mail ID. So usually you need to provide this DBA group mail ID so that if any job fails, the failure mail should go to these people. So in my case, I have my own personal email ID where I receive all the failures, where I want to receive all the failures. So I provide that email ID here, SQLagentservice@gmail.com. I advise not to touch any other parameter until you get any error. And in the error message, it says that you need to use this parameter. Okay, there is a question from Balaji. It says, if we have 100 plus SQL servers, we need to set up this on all servers, like edit the PowerShell script for all the servers. Yes, but if you see here, you don't need to set up, you don't need to change too many things. All you need to do is, you need to download the DBA tools only once on your local machine from where you are launching this wrapper script. That is point number one. And only thing which is changing here is these two parameters. Your inventory server would always remain same. Your inventory database would always remain same. Your DBA mail ID would always remain same. So the only thing which will change is all these server, the SQL Server Instance that you want to baseline and the DBA database there. But if in your organization, DBA database happens to be with the same name on all the servers, then you don't even need to change this line number 9. So only thing which you need to change for baselining 1000 plus servers or 100 plus servers is providing the name of the SQL Server Instance that you need to baseline. That's all, nothing else. So our script is pretty much ready. I want to baseline my experiment SQL Server Instance. The database in which I want to save all the baseline data happens to be DBA admin. My local DBA tools repository on the machine from where I am launching this wrapper script is present on this particular path. In my lab environment, my inventory server name is SQLMonitor and the inventory database is DBA. And in case of any job failure, the mail should go to this email ID. Don't enable any other parameters, okay, until you get any error. So we are ready for launching this script. Any questions before I fire this? Okay, I don't see any questions, so I am proceeding. So let me press on this execute button now. So there I go. So initially it will take around 20 to 30 seconds. Why? Because we are importing the DBA tools module. So importing the module takes little bit time. It is only one time thing. Once the module is loaded in a PowerShell window, then next time it will not take any time because module would already have been loaded automatically. So once DBA tool is loaded, now the script execution has started. So if you remember, I told you the main script is this, install -SQLMonitor.ps1. So what we are doing is we are calling this script with all these parameter values that we have defined here. If you want to baseline 100 plus servers, in those cases you can create your own wrapper script also. This wrapper script which I have provided you is just for your reference, okay. The main script which does all the magic is this particular script. So if you have 100 plus servers, what you can do is you can put all the servers in a file, loop through all the servers and call this install -SQLMonitor.ps1 by passing the server names one by one. That's up to you how you design your own customized wrapper install SQLMonitor script. I usually baseline one server at a time, so that's how I do. So you can see at what script or what step we are. So we are right now on step number 9. This script is working on step number 9. Now the question is, how many steps do we have? So to find out that information, you have to open this main script. So let's open this main script. I will go to this open icon, click on it. I will go back to my SQLMonitor folder, main SQLMonitor folder. In that there was a SQLMonitor folder again. So SQLMonitor, within SQLMonitor, and then here you will find that script, main script, which we are calling. So the main script is install-SQLMonitor, install-SQLMonitor. Open this one, and if you scroll down in this script, you will find out all those parameters. And in this, we have a total of 33 steps, which this particular script carries out. So from step number 1 to 33. And right now we are on step number 9. So in step number 9, right now we are copying the local DBA tools folder, which is in my case F GitHub DBA tools. We are copying this local DBA tools folder to SQL practice machine, the SQL Server Instance, which we are, sorry, not SQL practice, to this experiment machine, which we are baselining right now. Okay, even that step we have crossed. So we are almost at the end. We have total 33 scripts. Now we are at step number 29.
So Ajay, the question is, you have created a private folder, right?
Yes.
So when you are configuring other instances, I mean other SQL servers, so every time in your central server, do you need to create a private folder every time, or
No. It's a one-time thing. So why we are
because you
creating?
have created in the last two sessions also, like you have created private folder, right? So instead of using that private folder, you have created again.
Yeah, in those every time in the demo, I reset my environment altogether. I restore these VMs from snapshots. Okay.
Okay.
Yeah, that's why I'm doing. Otherwise, you need to create this folder only once in your laptop, office laptop, or your central
In
server.
central server, yes.
Yeah,
So once we create private server, a private
private folder.
folder in our central server, so we
Yeah,
don't need to touch again when we
yes,
configure other servers.
yeah, exactly. And you
Sure.
can again and again take the GitHub repository, take the latest from GitHub without any worry, because that private folder is never touched. And this thing is happening because we have a git ignore file here. So if I go back to my repository folder, SQLMonitor, you will see here I have a git ignore file here. Okay, so git ignore in GitHub, we use this file to say or to instruct the GitHub any, what do you call, version control software. Okay, so we instruct any version control software to ignore a particular directory or file by placing that directory or file name in git ignore file. Okay, so I have this git ignore file. In that I have told it that ignore any folder which has name work or volatile or private or sensitive or any name like this, org-project or temp script. So if I create directories with these names, they are always ignored. Okay, so they will never be overwritten even if I keep taking the latest from the GitHub repository. Okay, or even if I check save my local repository to GitHub, if I push my local repository to the GitHub, then also these folders are ignored, and these contents of these folders, they will never go to the GitHub. Okay, so for example, if you remember, I just created this private folder, right?
Yes.
I even added 2 files here. But if you see here in this source control, I don't see those files appearing here. Okay, but if I create my any other file, in any other directory, say that I create a file in this SQL queries directory, okay, then all of a sudden that file will start appearing in this source control. I don't want to do in SQL queries. Let me choose any other which I can easily do it. Say that this X event, okay. So I create a local file here in X event, say file, say I name it dummy.sql, okay. All of a sudden this will start appearing in this source control here, okay. So
Got it.
any folder which is in my which is present in my git ignore, that folder or file will always be ignored by the source control software. So
Sure.
you can keep taking the latest from the GitHub repository, and your local files will always remain intact if they are in private or work or any of these folders. That is the whole purpose of this thing.
Sure. Thank you.
Let me remove this. Done. Cool. So our experiment instance is baselined altogether without any issue. And we had around 33 steps in this. Then these step names are also present in wrapper script here. If you remember, from line number 20 till line number 30, we have all these steps mentioned here. But don't rely on this particular list, okay? Because sometimes I don't update these things. So before executing this wrapper script, if you need to know what all steps are there in this install SQLMonitor.ps1 file, open that install SQLMonitor.ps1 and copy these scripts, copy all those steps here. So right now we have 33 steps, copy them and paste them in your wrapper script. So you can see my wrapper is quite outdated. Here I have only 32. So I will replace them here. Now I have 33 in my wrapper. Okay. So let me explain you basic of all these steps that we carried out in background. Initially at the start, I display all these messages. So the message is we are baselining our experiment instance. Come on, man, don't take me to the last of the file. So we are baselining our experiment instance, and the database that we are using for storing the baseline data or captured data is dbadmin. If you remember, I told you guys that it is not a mandatory requirement that database name should always be DBA. It can be any name. So if in your organization you are using some other name, that is also perfectly okay. Second thing, what version of what version of SQL Monitor you are using, that you get to see in this second line. So right now it is 1.1.1. Next thing is, if there happens to be any issue while deploying this SQL Monitor and you want to get help, the first thing you should do is you should visit this URL which is mentioned in this third line. So in this third line, it is saying for issues with this version, kindly visit this URL. So simply copy this URL, open browser and go to that URL. So on that URL, for this version I don't have URL. Let me go back to the previous version URL that I have there. So for previous version URL, I have this discussion opened here, and this is even valid for this one. So here you can see what changes we have made in this version and what are the common errors one can get if he is upgrading, if he is using this version, okay, and what action we need to take if we want to resolve that issue. Okay, if you are installing it for the first time, there is 99% chance that you will not face any issue at all. But if you are upgrading SQL Monitor, in those cases you may face a little bit error. So in those cases you want to visit the URL which is mentioned in that message, log message. Okay. So I copied this URL, I went to browser and I opened that URL, and that URL gave me what enhancements that has been done in this version. and what kind of errors you can receive while upgrading and what you need to do to resolve those errors. After that, we start everything. So there are some steps in background, okay, which involve creating SQL Server agent jobs, and those SQL Server agent jobs call PowerShell scripts. Okay, what are those steps? These are those steps. So we have about 5 steps which run PowerShell jobs in background. Okay, so we create 5 SQL Server agent jobs which call PowerShell scripts. The names are collect disk space, collect OS processes, collect performance data, update SQL Server versions, check instance availability. So these 5 jobs they call PowerShell scripts. Then we have 3 steps in which we RDP the SQL Server instance which we are baselining. So we baselined experiment machine. So we RDP that experiment machine and we perform some kind of activity. The first activity we perform after RDPing that machine is copy the DBA tools folder on that remote machine. If you remember, we provided DBA tools local path in this parameter, DBA tools folder path. So we provided the DBA tools local path which we downloaded from GitHub. We copy that folder on remote machine in this step number 9. So all the steps which need to RDP the SQL Server instance which we are baselining, they are mentioned here. So we have total 3 steps in which we need to RDP the machine. So step number 9 where we copy DBA tools, step number 10 where we copy the perfmon folder. So inside SQLMonitor we have this SQLMonitor folder. We copy this entire SQLMonitor folder on the remote machine on the default path of C SQLMonitor. Okay, this path is entirely customizable. I prefer to keep C drive because it is always easy for me to remember where I kept my SQLMonitor path on the remote machine. Okay, but if in your organization people are very sensitive of not using C drive, in those cases you can change this, you can uncomment this parameter and you can save the SQLMonitor scripts to some other folder or path or other drive. In my case, I prefer to always keep this C drive. So what does this mean is, earlier in C drive on experiment, we did not have any user folder, but after this script execution, after the baselining of experiment machine, what happens is, in the C drive, we copy this SQLMonitor folder. So we are inside experiment and we copied that SQLMonitor folder here. So you can see all the scripts which were present in SQLMonitor, including the wrapper ones and our main script install SQLMonitor. The entire folder, SQLMonitor folder, is copied on the machine which is being baselined. Okay, and size of this folder is in few KBs only. You don't need to, in few MBs only. You don't need to worry about the size here. The size is only 5.32 MB. That's all. So if people argue you about keeping your folder in C drive and they are worried about space, you can always convince them that this folder is of very small size. Still, if they are worried, that if they still say that you should not keep anything in C drive, then definitely this parameter is entirely customizable while deployment. You can uncomment this line number 13. The parameter name is remote SQLMonitor path, and you can provide a different path altogether. So this SQLMonitor folder would get copied on totally different path. Even that is possible. In my case, I prefer C drive because it is easy for me to remember. Otherwise, in my production environment, we have so many drive letters. Pretty much all the drive letters are utilized in my environment. If it is a clustered active clustering kind of setup. So all the drive letters are utilized. So in those cases, it is messy for me to find out where my SQLMonitor folder is. So in those cases, I prefer C drive only. But as I said, in your case, you may change this if you like. The next RDP parameter is RDP step is set up perf_mon data collector. So in this tool, in background, we create a perf_mon data collection for you. Okay. So if I go back to my experiment instance server, and if I search for performance monitor, I expand this data collector set, user defined. There you will find that we have a data collector running. The name of the data collector is DBA. Okay. And the files of that data collector are going into C SQLMonitor. So if you remember, we are copying the SQLMonitor files in C drive, C SQLMonitor. So within that folder, we have a folder called perf_mon files, and our perf_mon files are getting saved on this particular path. Okay. So this is the third step for which we need to RDP this box experiment machine. So total three steps we have for where we need to take RDP of that machine. Not exactly RDP, we are taking PowerShell session in background. And we have 5 steps where we create SQL agent job which call PowerShell scripts in background. Rest of them are T-SQL steps. That means SQL agent jobs which call T-SQL scripts. So starting from the top, just some debugging messages. Then we tell how many PowerShell scripts steps we have, how many RDP steps we have. Then we output all the variable values and how many steps that we are going to execute in this script. So total we have 33 steps in this script to execute. Post that, we fetch the basic information about the SQL Server instance which you are baselining. So we were baselining experiment SQL Server. So this is how the experiment SQL Server looks like. What domain it is part of. If it is not part of any domain, then you will see work group keyword here. You will see the name of the SQL Server instance, machine name, fully qualified SQL Server instance name, the host name of the SQL Server instance, version, and then we will see what is the service account name. Okay, in both of these formats. So service account and service account name and the service account altogether, service name altogether. Post that, we set up some local variables in background, so you would be able to see all those variables here. In order to execute the 3 RDP steps, we take a PowerShell session. We create PS session in background. So this is how the PS session looks like for that machine. And then we start executing all the basic things on that SQL Server instance, like creating the database, creating all the basic tables in background, ensuring that all the basic checks are valid there. Okay, so you can read each and everything in this log, and I rather advise that initially, until you get 100% familiar with this tool, go ahead and read each and every message in this tool. That is highly recommended. Okay, so pretty much all the 33 steps are done. Now once this is done, if I connect to my instance, so I have connect now this, so let me disconnect it again. So I will connect to that experiment SQL Server one more time, and now you can see earlier we created this DB admin fresh, but now it will have multiple tables. So we have around these many tables in that. Okay, and on the same server, earlier we did not have any job. Now we have these many jobs. If you remember from the setup log, we had around 5 steps, okay, which were running PowerShell scripts. The step name was collect disk space, select OS processes, collect perform data, and these two jobs, they are created on inventory server, not on the server which is being baseline. So you can ignore these two last jobs. So 3 jobs which run PowerShell scripts. So I go back to SSMS and I open job activity monitor. I want to ensure that all the jobs are running fine here. So you can see all the jobs, the last outcome has been succeeded. So in short, all the jobs on my server are running fine. On this experiment SQL Server, every job is running fine. Just to do one more validation, I will simply right click on any job which is running PowerShell script. For example, this perform data, and I will check its history here. So view history, and this job has run these many times successfully. I want to check the latest log. So I expanded the last job execution, starting from the bottom output in that job. I can keep my keep scrolling up. So here you can see output is changing, and in this you will see what this job is doing in background pretty much. Okay.
Ajay, while executing these jobs, right? So do we see any load in the server because of these jobs?
You can see how fast these jobs are running. Okay. 20 seconds. Okay. For perform data collection, which is nothing. For weight stats collection, just 1 to 2 seconds. Okay. For disk space informametric collection, pretty much very small time, 20 seconds. Okay. So all these jobs are very optimized. They take very less time and they take very less resources. Now, getting back to your question, you can verify that thing from SQLMonitor itself. Okay, that is the whole purpose of baselining the server, so that we can check what is causing what kind of issues on the server. So you can go back to our dashboard. Since this this experiment server is baselined now, if I refresh my all server dashboard, I refresh this dashboard here, I mean the entire browser tab, then I should see my server here in all servers list. So there you can see now, I can see my experiment server. You can see the basic details. This server is of 2019 version, 4 CPU cores, 16 GB RAM. Okay. Uptime has been only 0 days. Now, that server is not appearing in any of these two rows. So it is neither offline, nor it need any kind of DB attention. It is not present in this list also. So what I will do is, I will go to our next dashboard, which is monitoring live distributed. And from this list, I will choose my server, which is experiment. So here I go. So there you can see OS CPU utilization 12%, SQL Server utilization 0%. So we are not putting any kind of pressure on the SQL Server itself at all. 88% of the time, SQL Server is not doing anything at all. The entire operating system is not doing anything at all. 12% it is doing some kind of work because we have RDP'd. So general recommendation is we should never RDP the box until it is necessary. Okay. So let me log off. I don't want to log off because we may need to come back here. But the idea here is SQL Server, since all the jobs are running from within SQL Server CPU is literally negligible. Okay. So these jobs do not definitely any kind of monitoring or any kind of monitoring tool you install, they will have some kind of overhead. Okay. Even if you run select star from sys VM exec request, VM exec session. Even that query gets compiled. Even that query gives you data from DMV. That's what we are doing in background. Okay. So every query needs some kind of CPU or memory. But in this infra, the queries which I have written, they are quite optimized. So the workload, the resource consumption is pretty minimum. Okay. So you should not worry about resource consumption of this tool at all. Okay.
Sure.
So now this is how we can see those things. CPU
Ajay,
utilization looks like this.
Ajay, I have one question.
Mhm.
Actually, that the DPA tool path, actually, that is one of the parameters. That path should be created all baseline server, or it is only for centralized server?
That DBA tools path,
Yeah, I mean line number
you can see the
9.
path name. Okay.
Okay,
It happens to be local folder on the machine from where I am calling this wrapper.
okay, okay,
Okay.
okay.
I am
So
calling
anyway,
this wrapper script.
the wrapper file should be run on all baseline server. So
No, no,
suppose
no.
oh,
You can see my scenario, right? I am running this script from workstation.
okay,
Okay. But I am baselining some different machine and my inventory server happens to be different machine.
okay,
Okay. So
okay,
it is nothing related to the instance which is being baselined. It is
okay,
nothing related to the inventory server. This
okay.
folder is all related to the server or
Where we are
the
running the machine.
laptop where we are running this wrapper script.
Okay,
Okay.
okay,
So I am
okay,
running
okay,
this wrapper script from my workstation machine.
okay,
So that's why this folder path is local to my this workstation machine. So if I
okay,
copy this and if I run say test path here, you will see yes here. So in short, this path is local to this machine.
okay, okay, got it,
Okay.
got it. Okay,
It has nothing to do with the remote machine or inventory machine.
okay, okay.
Okay.
So, okay, so based on that, so we can run that, I mean, at the baseline server, if any one machine. That server can be apart from inventory or like baseline server, right?
Yes, that server
Oh,
can be anything. I usually in my office environment, this server,
okay,
this server from where I launch these wrapper scripts happens to be my office laptop.
okay, okay.
I
But
don't.
but
Uh,
I mean the baseline and the central server and the workstation, all of them should be in same level so that only they can communicate. Am I right?
yes, best way is to do all these things from your central server.
Central server, I mean the domain should be same. Am I right?
See, in last demo, the two previous videos,
Okay.
you saw that we can even use this to baseline even non-domain servers.
Okay. Okay.
Okay, so even
But okay.
non-domain servers work. You don't need
Okay.
to worry about that. I will even show in next demo. I will even show you that scenario where I will use this machine, my
Okay.
workstation machine, to
Okay.
baseline a server which is not joined to any domain.
Okay. Okay.
Okay,
Okay.
so
Okay.
this tool is entirely flexible.
Okay. Okay. Okay.
Okay, you can install SQL Monitor from a third machine.
Okay.
Inventory could be third server, and the machine which you are baselining could be third server. Okay.
Okay. Okay.
Okay. Don't worry about this thing. This tool is entirely flexible on that term. The recommended way is you do everything from your central server.
Okay.
Okay.
Okay. Okay.
And so that so that every person in your team, they can carry out the same activity using the same standard. Okay. In
Okay.
my in my environment, in my office environment, I use my personal office laptop altogether, not the central server, because I am more comfortable with my office laptop. I don't like to RDP the SQL servers and then do activities. I prefer to take PowerShell remoting to do all kinds of activities. So I do all these things from my workstation machine, from my office laptop. Okay, but the easy way is to RDP this SQL monitor and do everything from SQL monitor. That means your inventory server or central server. Cool.
Yeah. Yes. Yeah. Thank you.
Yeah. Okay. So what we were talking about is yeah, we were discussing this dashboard. So now our experiment server is back, is added in this inventory, and you can look through all the metrics that we talked about earlier. I can choose the date time frame to be 1 hour, and we don't have previous data because we baselined the server around this time. Okay, so we are getting CPU information, all the basic operating system level information, SQL Server level information. If there is any blocking view, you will get the blocking tree here. Okay, then memory grants, winsock rejections, long running queries, all those things I have already explained in previous videos. Okay, for example, let me choose SQL practice where my workload is always running. So for SQL practice, you can see everything is in yellow and red. Our operating system CPU is 86%, SQL Server is utilizing 73% of it. There are around 3 sessions which are blocked over 60 seconds. The longest blocking is of 3 minutes on my server. Okay, and there is something wrong on the server going on because waits per core per minute is above 1 minute. It's 1.31 minutes on my box. My server is pretty much delayed in terms of patching. The latest patch which is available for SQL 2019 is CU18, and the latest patch which is applied on my box, SQL practice box, is CU16. So I am 2 patches behind, two cumulative updates behind, and there is a gap of 15 weeks in this patching. So pretty much all the basic information now you have at your fingertips from these dashboards, and we have around 5 dashboards, so you can go through all those dashboards to see what is going on in any of those. For example, if I want to see what is going on this SQL practice machine, so I can simply click on this SQL practice machine, SQL practice name, and it will take me to this live distributed dashboard. But if I want to analyze the weight stats, I can click on this particular row, this particular value 980, and it will take me to the weight stats dashboard. So I can go to this last row and say I choose 6 hours here. So you can see pretty much between 5 p.m. till 6:10 p.m. or 6 p.m. there was nothing running on the server. But from 6 p.m. there has been heavy workload running on the server, and what kind of activity it is doing, you can see this blue color is covering the major portion in these vertical bars. So blue color is representing LCK-MIX, intent exclusive lock. Okay, so they represent lock wait type. So in short, my server is facing blocking issues since 6 p.m. today.
Ajay, actually, sorry for the so much. Okay, but in that scenario, you see that the blue color is indicated the blocking. Am I right?
Mm-hmm.
So how to find which query was getting the blocking? How do we find further drill down?
You go to this live distributed dashboard.
Okay.
Okay, choose your server.
Okay.
Choose your time frame for which you want to look for the blocking. Say that I am interested in last 15 minutes only.
Okay.
Okay. Then there is this row, blocking tree.
Okay.
You expand that row.
Okay.
And you will see all the blockings that happened in last 15 minutes.
Include that. Okay. Include the query as well. Okay. Okay.
Yeah, it includes everything. So you can see the snapshot. So this blocking is captured at 21:38:04. Okay.
Okay. Okay.
28:34. Where is this? 28:34:04. So these 3 rows have been captured at this time. Then these are of different time slots. Then these are of different time slots. Okay. So we run who is active every 2 minutes and capture the data. Okay.
Okay.
So whatever time frame you choose here,
okay,
we will show who is active data for that time frame in this row, but by filtering only for the blocking information.
Okay.
So now here you can see the lead blocker and the sessions which have been blocked.
Okay.
Okay. So session lead blocker here is session ID 65.
Okay.
Let me stop the refresh so that this data do not go away. So our lead blocker is session ID 65. It is running this stored proc USP report 2.
Okay. Okay.
Okay. And that session is blocking this session ID 68.
Okay.
That is running stored proc USP comment insert.
Okay. Okay.
Okay. And if I scroll down any other time, yeah. So let's choose another time frame in this last 15 minutes of time window. So around 21:48. Okay.
Okay.
There was a head blocker 76. Query was USP report 2. It was blocking our session 71. The query was USP post viewed. That 71 was blocking some other session. Session
Okay.
ID 64. The query was USP comment insert. Okay. And same session 71 was blocking 74 and 81 also. But
Okay.
71 was getting blocked by the head blocker 76.
Okay.
Okay. Now we have another column which says blocked session count. Okay. So if you are only looking for the head blocker,
Okay.
you have to go for the session which has maximum number.
Okay. Okay.
Okay. So in any time snapshot, for
Okay.
example, time snapshot is 21:46. Yeah.
Okay. Ajay, actually one doubt actually. Here, some scenario within the SP, we have built a lot of query. Actually, there is chance for in our production room and within the SP, we have built around 10 to 20 black ops sessions query we have built. So in that scenario, we particularly want to which query getting the blocking or which query making the blocking. So we want to detail of, detail of respective query. So in this scenario,
You
here,
have that information here. Don't worry. So this is the blocking tree. If you scroll to the right,
okay, yeah,
okay,
yeah,
you will see even the queries here. Is it not mentioned here? Okay.
okay,
It is not appearing in this dashboard because this dashboard is created only for end users.
okay,
Okay. Now for DBAs, what
yeah,
you want to do here is you want to look for the query. So you click
oh,
on this drop down, you go to
okay,
the inspect query.
wow, wow, wow,
Okay.
wow, okay, wow,
Okay.
wow,
You copy this query.
okay, yeah, yeah,
Okay. Whatever query is being shown here, you copy this query and you run that on your server. So
okay,
I will go to this experiment server. On experiment server on DBA database, DBA admin database, which is storing all the baselining, I can come and run that query. So remember, since we selected that dashboard for last 15 minutes, okay?
okay, okay,
So that data at that time, the time frame at that time was this much,
okay, okay,
okay, in UTC.
okay,
Okay. So all you need to do in this thing is you simply comment these two things out, this line out, okay,
okay,
and this also. You simply run this much, okay,
okay,
and
okay,
apart from above code. So the same data which you see on the dashboard,
okay, okay,
you see here on this, okay.
okay,
Sorry,
okay, got it,
I am running
yeah,
on wrong server. It should be SQL practice.
yeah, 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 I got it, yeah, got it, yeah,
No, just one more minute. I want to show another thing here. So come on, man, DBA database. Okay, now thing is you will get all the columns which you were seeing on that dashboard. What
okay,
you are interested in is you want to see other columns from that result. Okay, so just do one thing. Simply do select top 100 from the table name. If you scroll up, you will see the table name here. Table name
yeah,
is dbo.who is active.
okay, okay,
Okay, so simply do top 100 from dbo.who is active. Okay, and from in dbo.who is active, we store the outer command also. That means you are running a stored proc, then you will get the stored proc name like USP vote insert, USP comment insert. Okay,
yes,
USP
yes,
report.
yes, yeah, got it, yeah, got it, got it, got it,
Yeah, and you have another column for the exact T-SQL which is running that statement. Okay, so in report you are running this statement which is blocking others.
Yes. Yeah.
Okay, for more details there is another column also. If you scroll to the right, then you have another column called additional info.
Additional info. Yeah.
So even that sometimes has the blocking information.
Okay.
Okay. Plus you get the execution plan also.
Yeah.
So pretty much you have too much information to troubleshoot whatever you want.
Okay.
Okay.
Yeah. Okay. Can you show me again what options you are trying to get the detail of query information? Can you show me in the dashboard?
Sorry, what option?
I mean, what options you have used for to get the that detailed query information in the dashboard?
In dashboard you can get everything. So this was one.
Okay, this was one. Okay.
Blocking tree was one. Now say that if you always resolve the blocking issue when it is happening, okay, or by looking at the queries, you never get the full picture.
Yeah.
Okay. To get the full picture, you have this particular row which says lead blockers.
Okay.
Okay. So what I do is I choose last 3 hours in time frame.
Okay.
And I expand this lead blockers here.
Okay.
And then I get to see what logins are creating maximum blocking on the server.
Okay.
So now I can raise a request for these people, whoever owns those logins, saying that, hey, your logins are creating the maximum blocking on the server and causing the server issues. Okay. This is really helpful because this way you are not looking at individual queries. Now it becomes responsibility of individual login owners to write their queries in such a way that they don't cause these much blocking. Okay. Second thing, the same information is available at login plus program name also.
Wow. Okay. Where it is coming from the request. Okay.
Yes. In the next panel. So now if they are interested in knowing what application for that login is causing this much blocking, we even get that here. Okay. So this is for getting the full picture here. I want you guys to watch all these videos which are there already. I have explained all these things in these videos. So one video is for one dashboard altogether.
Okay.
So any other questions on this demo?
I'm okay with the.
Cool. Let me explain just a couple of more background things and then we will wrap up our session. Okay. So in background, what things we did? I want to explain those things. Just a quick overview. In future, I will create detailed videos also. But in background, just to show you guys, in DBA admin database or the database which you mentioned during baselining this server, we create these many tables. Okay. This table blit index, it stores your index usage details. Okay. So what database, what table, what index, what kind of reads, writes it has, what columns you are using in that index definition, what data types they have, okay, how many rows are there in that index, whether there is any secret columns behind in the index that you are not aware of, whether it is unique index, column store index, non-clustered column store index, clustered column store index, whether it is part of any foreign key also, okay, reads, writes, inserts, deletes, or be using that index, singleton lookups, whether it has any partitioning, how many rows are there in the index, okay, whether this index is involved in blocking or not.
Ajay, secret column means what is the meaning here? Secret column means what is the meaning here?
Probably I don't want to take that in this session.
Okay.
We can take that in future sessions. But the secret simply means is whenever you create a non-clustered index. Okay. With non-clustered index, your clustered keys always go in background.
Yes, by default, yeah.
Yeah,
Yeah.
that is called secret key. Okay,
Okay.
even if you don't want, the
Okay.
clustered keys are always part of non-clustered index.
Yeah.
So that is what is being represented here as secret key. I don't want to go too much deeper into that. We will take future sessions in those things.
Okay.
If
Okay.
you guys are interested, of course,
Okay.
because
Okay.
these are very deep concepts in short things. So,
Okay.
okay. Sometimes you can see even uniqualifier here.
Okay.
Okay. So uniqualifier simply means your clustered index was not a unique or a primary key.
Okay.
So in order to make rows unique, SQL Server added some background identifier, and
Okay.
that is called uniqualifier.
Okay.
Okay. So you
Okay.
can see here, this is my clustered index on this table.
Okay.
Okay. Here you can see create clustered index definition name. If I go to the scroll to the right, here you can see partition by this, and it happens to be CX. CX means clustered index. So my clustered index is not a primary or unique key index. Okay.
Okay.
In those cases, SQL Server adds a number in background to make
Yes.
each and every row unique. That is called a secret column unique qualifier. Okay.
Okay. Okay.
So I want you guys to just search on the Google for SQL index and
Okay.
go through all the videos. You will understand what these columns are.
Okay.
We can take these in future, but not in this demo. So
Okay.
what I was explaining is what tables we have. So we have SQL index through which we store all the index usage details. Idea
Okay.
of this table is we want to find out what tables are not getting used at all,
Okay.
what
Okay.
tables are getting used in wrong way.
Okay.
Okay, what tables people created but they forgot to delete those tables. They were just for backup or dummy tables.
Okay.
All these kinds of questions we can answer from this table in future. I don't
Okay.
have dashboards yet for this, but in
Okay.
future I plan to create dashboards so that we can answer all those kinds of questions.
Okay. Okay.
Okay. Second, we have this table disk space, dbo.disk space. So this stores disk space information. Whatever disk drives you have on your server, how much they are utilized, how much free space they have, that table stores that information. And this data is being exposed on your dashboards also. So in monitoring live, if you go to the bottom, there is this row, disk space, and here we are exposing that information. Okay, you will even see the mounted volumes. These are mounted volumes in my case. The third one is file IO stats. Okay, the intent of this table is, again, for this table also we don't have dashboards yet, but the intent of this table is I want to find out what database file is causing the maximum IO on the server if my server is facing IO related issues. Okay, between what time frame my server is having the maximum load on the disk level. Okay, between that
Okay.
time frame, which particular database file is having the maximum IO hit. Okay, which database file is having the maximum number of disk queues or IO requests. What is the latency per file? Which database is the one which I should split into more files? Which database is the one for which I need dedicated disk drives? All those questions can be answered from this table altogether. But I don't have dashboards yet. That is the plan in future. If you guys can write your own dashboards, you are free to welcome. Okay, and you can
Okay.
share those dashboards for me if you like. But that data is entirely available in these tables.
Okay.
Okay. So yeah, this is going to be really very helpful in future if your servers are having IO related issues. We already have IO related dashboards in Quest software. For example, if you go to this dashboard, the dashboard name is Performance Counters Quest software. We do have IO related latency metrics. If I choose my server SQL practice, which always have workload, and if I go to this logical latency counter, logical disk counter, here I can see all those things. What kind of disk queue my disks have, what kind of latency they are having, okay, what kind of what kind of disk throughput they are giving me. For example, this is data drive, okay, per second in last capturing it gave 1 GB of throughput. So my disk is giving me 1 Gbps of speed, which is really good. Okay. So these things are getting exposed here also, but there are some scenarios which are not covered in these dashboards. In this performance matrix, this is getting captured from performance. So we have those tables which will answer all those remaining scenarios. Okay, those scenarios we will get from file IOStat. Like I said, at the file level. For example, what database I should give a dedicated disk drive. If I have to answer that, for example, in my organization, all the databases go in E drive, okay, and E drive is showing latency. I want to find out what is 1 or 2 databases for which I should create a dedicated disk drive. Then I will use this new this table data file IOStat. Okay, then we have these two tables, instance details and instance host. I think I already explained about them in at the start of the session. Instance details always store the basic information about the SQL Server instance, okay, which we baselined in SQLMonitor infra. So currently we are running this script on individual server which was baselined. So it stores all the basic information for that server. The name with which we baselined this server was experiment, but this is the host name, this is the database name, this is the T-SQL jobs server where we created the T-SQL jobs. This is the server where we created PowerShell jobs. This is the server where we are saving the data. Why we have these 3 columns? Because SQLMonitor is very flexible tool. Using SQLMonitor, you can create your PowerShell jobs on different server altogether. You can create your T-SQL jobs on different server altogether. You can save your data altogether on different server. Okay. How this is helpful? This is helpful in those scenarios where your server which you are baselining is not capable of running PowerShell jobs. Okay, where your server is not capable of running T-SQL job. For example, if your server is an Express Edition server, Express Edition do not have agent, right? In those cases, you want to run the PowerShell jobs and T-SQL jobs from other servers, maybe from your inventory server, which is the best choice. You can run your jobs from inventory server. Okay, so in those cases, your T-SQL job server, your PowerShell job server could be different. Okay, if you want to save your performance data all together on different server, you can even do that. If you want to keep your SQLMonitor script path on different folders, you can even do that also. Okay, what version of SQLMonitor you have deployed, you even get to see that thing here. Cool, guys?
Yeah.
So this was one table. The same table will give you different result when you run this query on your inventory server. Okay, because if you remember, on inventory server we store information of all other servers also which we have baselined. Okay, so on inventory server we get one line for all the SQL Server instances which we have baseline. So this is the only difference between local versus inventory. Apart from that, inventory server has couple of more columns like is available. So if the instance is offline, then you will see this is available equals to 0. So this inventory server has just couple of more lines extra. Apart from that, it has exactly same number of columns and lines on other instances. Okay. Getting back, what other tables we want to discuss? Next, we have this OS task list. The OS task list is storing the data of whatever OS level processes are running on your server. Okay, that data is again getting exposed on this live distributed dashboard, this one. Okay, so this OS task info is this one. OS task processes CPU utilization, OS task processes memory utilization. I already created blog posts on how to resolve CPU issues using SQLMonitor infra, and in one of those blog posts I am using these dashboards, explaining how to use these metrics, what they represent here. So I would request you guys to read those blog posts. Okay, then we have perfmon counters. This is storing all the perfmon related metrics. Then we have this purge table, dbo.purge table. This is really good table which you should know about. Okay, so in the dbo.purge table, okay, in this table, whatever tables we have in SQLMonitor infra, we are defining what should be the data retention policy. Okay, so for blit index we are keeping the data for 14 days. For disk space information we are keeping the data for 14 days. For IO stats also we are keeping the data for 14 days, 7 days. Okay, 14 days. If in your environment, based on the space policy, you want to increase or decrease the retention policy, increase or decrease the data, you should come to this table and update the retention days parameter here. Okay, so if you have very less space on your disk drive where your DBA admin files are there, then you want to reduce the retention days. If you have good enough space, okay, in those cases you want to increase this space, increase the data retention. Cool. Or say that there is a particular table for which you use a lot, which is very useful for you. You want to keep the data for longer time, for example weight stats. Okay, in those cases you can increase the retention for that table only and keep the rest of them minimal value, whatever you like. This is highly customizable in short. You simply need to change this value here. And when this table data was pulsed, for example dbo.blit_index or dbo.diskspace, when was this table last pulsed, you will get that data from this last column, latest purge date time. So it was the data from this table was removed last time on this time frame, on this timestamp. Okay, so this was this purge table. Then you have resource consumption infra. On this one also we don't have any dashboard, but this is again one of the critical tables that I use. So I will not show this data on experiment, rather I will show that data on SQL practice.
Yeah. Ajay, actually, I mean the resource consumption table. Actually, mainly it is capture that there are two events. One is RPC completed. Second one is SQL patch completed. So both events only being captured. Yeah, okay.
Exactly. So only RPC completed and SQL batch completed.
Okay.
So any session, any batch request which came on your server, it would fall in either of these two categories. Okay.
Yes.
Either it would be RPC event or it would be a SQL batch event.
Yes.
So this way we are capturing any session which took longer than 5 seconds in our infra. Okay. Only clause here is it should take more than 5 seconds in execution time. Okay, we don't want to capture everything, because sometimes if your server is highly busy, in those cases there could be so many things to capture. We don't want to do that. So we capture any request which took longer than 5 seconds. Or if it failed or timed out.
Oh, Okay.
Okay, even if it took only say 20 milliseconds, but if it failed, then we capture that. Okay, but if a request completed successfully, then it has to run for at least 5 seconds of duration before we capture that.
Okay.
Cool.
Okay.
So
Yes,
if
yeah.
people complain of queries getting timed out, then it would definitely 100% be captured in our infra. If people are complaining for query running slow, okay,
Okay.
in those
Okay.
cases it should run at least for 5 seconds before we capture that.
Okay.
Okay, you have to remember this difference.
Sorry. Can you tell again? Yeah, sorry.
Okay, there are 3 scenarios in which we populate data in resource consumption.
Okay.
Okay, let me just look top 1000 rows. So there are 3 scenarios in which we capture this data.
Okay.
Okay, the scenario number 1 is when query is successful. Okay,
Okay.
and duration is above 5 seconds.
Okay.
Okay, second
Okay.
is query timed out
Okay.
or query failed.
Okay.
So timed out or aborted.
Okay.
Okay, so if a query got timed out or aborted, abort can
Okay.
be even within 1 second or within 30 milliseconds also.
Correct. Correct. Yeah.
Okay,
Yes. Yes.
so abort, we capture all aborts, all timeouts.
Okay.
It's that simple. We capture all failures.
Okay.
But
Okay.
if the query is successful, and it is running for over 5 seconds, then only we capture.
Okay.
Okay,
Okay.
successful queries has to run for 5 seconds before we capture them.
Okay.
Failures and timeout we always capture.
Okay. Okay.
That is the difference here.
Yeah. But here one thing I observed that actually that job which is for resource consumption, that job,
Mm-hmm.
it is trigger every 1 minute.
Mm-hmm.
Suppose the first time it is trigger, I mean 1 a.m. it is trigger. Okay. Second it will reoccur 1 a.m. 1 minute. Okay. In that between time interval, if anyone query is run within the 5 seconds, that information we wouldn't see in that resource consumption table. Am I right?
Yes, yes, definitely we will see. Because this
Yeah.
data is coming from X event.
Yeah.
Okay, this data is coming from extended events. So if you
Yeah.
go to management node in
Hmm?
extended events here, you will see that resource consumption running here.
Yeah.
Okay,
But
so in
but
extended events everything gets captured.
capture, but our jobs, I mean the SQL job for resource consumption, it
Yeah,
will
yeah.
be
So
trigger every 1 minute.
yeah. So it every 1 minute it will fetch all the information that is not there since last capturing.
Yeah, but whenever we try that information, we will stop and start. So when we stop, I mean when we stop
Hmm.
means that old information will be lost.
No, no. Who said we will lose the old?
But every time when we stop and start, and the new file will be created. Am I
No,
right?
no, no. Yes. So it will be created, but you configure the X event. You see here in data.
Okay.
So in this advanced, if you go here,
Okay.
do you see here what we are doing? We are saying per file the maximum size is 200. Okay, and
Okay.
we don't have any file rollover, what you call loss here.
Okay.
Okay, in my case the files will remain there as long as I want.
Okay.
Okay, that's why we have another job to delete the old files that I don't need.
Yeah. Yes, I got it. Yeah.
Okay, so this is
Yeah.
what is happening in my case. I am keeping the files until I
Okay.
read them,
Okay.
and
Okay.
once I am done with reading all those files, then we delete those files from the disk. So we don't have any loss of any event.
Okay. But actually, that resource consumption, that job, that job number, job name
Mm-hmm.
called, which one that name? I mean,
Mm-hmm. Yeah, yeah.
I mean XC1, you know that XC1 that job now. So
So
within the jobs we are every time we are trying to stop and start that Excel table,
yes,
right?
yes.
So once we stop that that even that old information, I'm not sure about that. That old information will be kept on that file or not?
Yeah, it would be kept, no? You see
Okay.
here how many files we have imported here.
Okay. Okay.
These
Yeah.
are
Yeah.
all, yeah, so many files.
Okay. Okay.
Okay, so that's what we
Okay.
do here.
Okay. 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 Yeah,
So
correct. Yeah.
no data loss at all. We are keeping the files on the disk until we process all the files. We don't delete them.
Okay. Okay. Yeah. I got that logic. Yeah. Yeah. Okay. Okay. Okay.
So this is, I think this was the last table, right? Or we have any other resource consumption, and then wait stats and who is active, which we already know all about
Yeah.
here,
Yeah.
right?
Yes. Yes.
So that's it, all about the basic table details. And stay subscribed to the YouTube channel and blog, because I would be writing a lot of blogs and YouTube videos, creating YouTube videos on how to use all these data to resolve your performance issues on the server. Because I
Yes.
create all these scenarios in my lab environment.
Okay.
Cool. Any other queries or questions before we wrap up the session?
I am okay with Ajay.
Okay. Thank you, Suresh. Thank you, Balaji. Thanks for joining. Have a
Yeah.
nice day.
Thanks. Yeah. Thanks, Ajay. Yeah.
Thank you
Thanks.
so much, Ajay,
Thanks
for
for.
your valuable time.
No worries. You are welcome. If
Yeah.
you guys want, we can take another session for non-domain server tomorrow.
Yeah. Sure. Sure. Yeah.
Okay.
Yeah.
Cool. So we'll connect tomorrow for non-domain server, but we will make it more complex.
Okay.
So what kind of complex we will make? We will choose a server where we have more than one SQL Server instance.
Okay.
Okay. For example, on my workstation machine, you guys already know that I have 3 SQL Server instances, and
Okay.
all 3 are baselined.
Okay.
So we will take a similar scenario tomorrow, where we have an instance where we baseline a host which
Okay.
has more than one SQL Server instance.
Okay. Okay. Okay.
So
Ajay,
yes,
I have one more doubt. I have
uh,
one more doubt. Actually, for that baseline server, we can combine with one server is a domain baseline server, another one server is a work group. Is it possible to configure the monitoring the SQL performance?
sorry, buddy, I did not get your question.
Sorry, one of the environment we have the one baseline servers. It is configured with domain. Another one server it is a work group. So is it possible we can both server can be monitored
Oh
using
yeah,
the
yeah,
SQL? Yeah. Okay.
yeah,
Okay.
yeah, definitely. There is no issue. As I
Okay.
said,
Okay.
this tool is literally very flexible. You can
Oh,
you can use this to baseline any kind of environment, even if it is mixed one. Okay,
okay. Okay.
so you can even baseline your Express edition of SQL Server, like I have done. If
Yeah.
I
Yeah.
go to my monitoring dashboard here, if I choose my Express edition, Workstation SQL Express, okay,
Okay.
and here you can see SQL Express edition is in offline state. It is always offline because it is Express edition.
Okay. Okay. Okay.
Okay, but from the dashboards you will see all the metrics. Okay,
Okay.
even the CPU utilization here. So how
Oh,
these jobs are running, how I am
okay.
capturing the CPU utilization, that is the question, right? So because all the jobs run through SQL agent job, and this Express
Yes.
edition do not have agent.
Yes. Yes. Correct. Yeah. Okay.
You can see here the Express edition 64 bit. So this tool is literally very flexible. You can baseline any kind of environment, be it domain or not domain, or be it mixed, where you want to monitor domain and not domain in a single environment. You want to even baseline Express edition, you can even do that also. And you
Okay.
can see here, this is the proof. Even Express edition is showing CPU utilization, memory, and all those things. So yeah, you can do anything with this tool.
Okay. Okay. Yeah. Yeah.
Yeah, feel free to use these guys, because as a DBA I faced a lot of challenges in past. I do lot of performance tuning, and without these kind of metrics, it was always very hard for me to uh, tell people what was the real problem. So that's why I started designing this particular tool altogether. And I don't want to keep it paid because I feel the pain of other people also. I felt the
Yeah.
same pain, and people never. I mean, all the tools which are available in the market, either they are paid or they are very non-user friendly.
Yes.
Okay, so that's why started creating my own tool, and this you can use without any worry. There would not be any licensing for this. Don't worry. Go ahead and use
Okay.
it. Cool, folks. Thank you. Thanks for joining. We will connect tomorrow then for another scenario.
Yeah. Yeah. Thank you. Thank you. Thank you. Thank you, everyone.
Sure. Thank you, Ajay.
Thank you, Suresh. Thank you, Balaji. Bye.